So now we are in part 4, the cosine rule proof in this lesson, and also we call it the law of cosine. Before giving you the formula, I would like to tell you how we got the formula. So it's very important to know how we got it, and then we will memorize it later on. First, if you have any triangle, we know that we can use Pythagoras just in a right triangle. But here, if it's not a right triangle, it's a scalene triangle. If I have the height in this triangle, I will name the side opposite to the vertex the same thing. So as if it's the vertex here, the side C, B, and here is A. If this side here is X, so here it's A minus X. If I'm working in the triangle I will name this point here D, ADB, what is the value of h using Pythagoras? We know that c squared is equal h squared plus a minus x squared. It means h squared will be c squared minus a minus x squared. And in the triangle ADC, what is the value of the height? Also Pythagoras. So h squared will be equal to b squared minus x squared. So the two heights are equal. So h squared equal to h squared. What can I write? I can write that c squared minus a minus x squared is equal to b squared minus x squared. If you develop here, it's a squared minus 2ab plus b squared. And then when you solve and you put all on one side, you will reach that you have c squared is equal to a squared plus b squared minus 2ax. And x, how do we find x? I can have it in this triangle, on the other, in this triangle. So cosine c is equal opposite over cosine c is equal, sorry, adjacent over hypotenuse. So it's x over b. So it's going to be x b cosine x. So and then now we can get the first formula of the cosine rule. It's c squared is equal a squared plus b squared minus 2ab cosine c. It's, if you look at it, it's a general formula of Pythagoras. It's we say it's the general theorem of Pythagoras. So c squared, this side is equal the other two psi squared minus 2 a times b cosine of the angle in between one. This is 90, cosine 90 is 0, so this is 0. That's why we're going to have c squared is equal a squared plus b squared, or the inverse. So every time I need to write the cosine rule, okay, every time I can write 3. So if I start, for example, by this side here, ab squared is equal ac squared plus bc squared minus 2ab times ac cosine the angle in between c. If I start by ac squared, this one, so I'm going to use the cosine of b. So it's ab squared plus bc squared minus 2ab bc cosine b. And if I start by bc, so it's ab squared plus ac squared minus 2 AB, AC, cosine. What is the angle between AB and AC? It's C. And then also we can deduce the cosine. So you can solve also to find cosine C, cosine B, and cosine A. To understand more this rule, we'll do some application, but all the time to use the cosine rule, I need to have uh, 3 sides, or I need to have 2 sides given and 1 angle. So they should give me or 3 sides, so I can deduce the angles, or they should give me 2 sides and 1 angle, and I can deduce the third side and the remaining angles. Let's start the first exercise. It's page 393, number 1. It's in the book. So let's start with the first one. Use the cosine rule to find the missing angles and side of the following triangles. And guys, I will not do all the application. I'll just do some of the parts here. So if I want to find, first you look which angle and side do you have. I have this angles and those two sides, so directly I can start with QR squared is equal 5 squared plus a squared minus 2. 5 times a is cosine 30. You replace, you get QR. I got QR. Now what I need, I still need to find another, now the angle. I have the 3 sides, so you can pick. Either you need to find the angle Q first, or this one, as you like. The third one we will find at 180 minus. So if I want to find the angle PQR, so how I will start with it? I'll start with the side opposite to it. So what is the side opposite to PQR? It's this one. So it's PR squared is equal PQ squared plus QR squared minus 2 PQ QR cosine PQR, and then you solve for this one. You got the cosine. How do you find the angle? On the calculator, you put shift cosine PQR and you will have the angle 115.46. How do you find the third angle? We know that the sum of the angles in a triangle are 180, so it's 180 minus the sum of the other two, and we'll get the third angle. We move to exercise 2. They said here, find the largest angle in the triangle ABC given that A is 4.5, B is so. When I draw a triangle, the largest angle is all the time opposite to the largest side. So if I do a small sketch here, and if I want to draw it, which side is the largest one? 4.5. This one is the largest one, so I name it ABC, okay? uh, we have A opposite to AC. So this is the largest side A. It means the largest angle is big A. And then I use the general formula of the law of cosine, we can say. So we say it in French, the théorème de Pythagore généralisé. So in English, it's the law of cosine. So it's CB squared is equal AC squared plus AB squared minus 2AB times AC cosine A. And all we need to do is to replace, we solve, and we find the largest value of the angle. All the calculation you can do it on the calculator. So I will not lose my time doing the calculation during the video. Now, another exercise number 3. They said in triangle PQR, the sides PQ, QR, and RP are in the ratio of 3, 2 to 4. What does it mean? It means that 3PQ is equal to 2QR is equal to 4RP. Find the smallest angle of the triangle. Again, the smallest angle should be opposite to the smallest side. How I can find which one is the smallest side? Use multiply 3 by PQ to give me the same answer as 2 times QR, the same answer as 4 times RP. So the smallest side is the side that I multiplied by the biggest number. So the smallest side here is RP. It means if RP is the smallest side, so the smallest angles will be Q. So to find cosine Q, so I'll start with the side here. So RP squared is equal QR squared plus QP squared minus 2 QR QP cosine PQR. Again, here I don't have the measurement, so I need to replace it all in terms of one of the sides. I picked RP. So by what I will replace QR? I will replace QR by, it's 4RP over 2. It means it's 2RP. 2RP, sorry. By what I replace QP? If I want to find QP, I will solve here this and this. So what will be QP or PQ is equal 4RP over 3, and then I just replace. Here I will have RP squared is equal 4RP squared plus 16 over 9 RP squared minus 4 times 4, 16 over 3 RP squared cosine Q. Then I need to solve. I'll take all to one side, this, and this. So I will have 16 over 3 RP squared cosine Q is equal 43 over 9 RP squared. We simplify RP squared. When I take it here, it's division. And I got the cosine. Then using the calculator, shift cosine 0.89, and I will have the smallest angle is 26.38 degrees. Number 4. Triangle ABC, we have the figure has sides of length. We have 5x to x minus 1. And given that this angle is 60. Find x and hence calculate the other two other angles. So first you need to find x. It means I need to find the side. To know where should I start, I need cosine. Which angle is given? 60. So this cosine that I need to use, it means I will start with this side here. So this one gonna be the first side. So 2x minus 1 squared is equal 5 squared plus x squared minus 2. 5 times x times cosine 60. I just replace, I solve for x, and I will have a quadratic equation. 3x squared plus x minus 24. This one I can use it a calculator, delta. It's linked to if I'm using calculator or not, and I will have two values for x. X is minus 3. This is rejected. Why it's rejected? Because the side cannot be negative. And the other value of x, 8 over 3, this is accepted. Now you can replace x by the values. You will have 5. You will have any other two angles. So it's enough to find one angle. Then the third one we do 180 minus. You can, for example, start by this one. AB squared is equal BC squared plus AC squared minus 2BC times AC cosine C. Then we will find the angle C. It's 87.8. And to find the third angle, I just do 180 minus the other two angles, and I will get the third angle of this triangle. Let's move to Another exercise, number 5 now. Number 5, a parallelogram ABCD has sides AB and AD of lengths A and B respectively. The diagonals AC and BD have lengths P and Q as shown in the diagram. Show that P squared plus Q squared is equal to this. First, I will take the first parallelogram here because I need P squared. The first, triangle ADC. In this triangle, I have this is BD and this is A because opposite sides in a parallelogram are equal. And here I can put P. So in this triangle, since I need what is P squared, so I will write P squared. P squared is equal A squared plus B squared minus 2 AB cosine ADC. Now in the other triangle, DCB, I will make it in yellow, this one, DCB, I can find Q squared. What is Q squared? It's A squared plus B squared minus 2AB cosine DCB. Now, if I add those two, I will notice that I will have 2A squared plus 2B squared, but I have the problem with the cosine. But we know that in a parallelogram, consecutive angles are supplementary. It means that ADC and DCB, their sum is 180 degrees. It means that I can replace DCB by 180 minus ADC. And this is the formula that we did in the preceding lesson. What is cosine pi minus alpha? Cosine pi minus alpha, I'm in quadrant 2. And cosine in quadrant 2 is negative, so it gives me minus cosine alpha. It means I can replace cosine DCB by minus cosine ADC. And minus and minus, this one gonna be plus. Now I add P squared plus Q squared. I'm gonna have B squared plus A squared minus 2AB cosine ADC plus A squared plus B squared plus 2AB cosine ADC. Those two, they cancel each other. So I will have 2B squared plus 2A squared. Visible factor, it's 2 factor of A squared plus B squared. And I got the proof done. It's proved. I got the result. That's it for this video. In the next video, I will continue part 5 and hope you got it. Repeat the video well to understand more the lesson. See you in the next video, guys.